Assalamualaikum. Today we will learn subtopic 10.3 Sound Intensity. Objective of this topic are: A. Define and use sound intensity. B. Discuss the dependence of intensity on amplitude and distance from a point source by using graphical illustration. Sound intensity is defined as the rate of sound energy flow across unit area perpendicular to the direction of the sound propagation. Mathematically, I is equal to E over dA. We know that power is equal to energy per unit time. So, I is equal to P over A, where I is intensity of sound, E is energy of sound, A is area, T is time taken, P is the power of sound. SI unit for sound intensity is watt per meter square. Sound intensity is perceived by the ear as loudness, which is the sensation produced by a combination of the ear and brain. Mr. Z will explain more details. Please listen to the video.
The human ear can detect sounds with an intensity as low as 10 to the power of minus 12 watt per square meter, and as high as 1 watt per square meter. It means that the loudest tolerable sounds have intensities which are 10 to the power 12 times greater than the faintest detectable sounds.
Okay, thank you, Mr. Z. By refer to this diagram, as we consider as S to be a point source wave, so that is the reaching wave in all directions in 3D space, and can to be considered the intensity of wave in distance r from the point source. So we can say that power from the source is covering the area A. So we can say that intensity at distance r is equal to the power per unit area. If now we consider at distance 2r away from source S, we have the same power that passed through the area A at distance r is now passing through the area of 4A at distance 2r from S. So can say that intensity at distance 2r away is equal to the power divided by area 4A. By double the distance, we have a quarter the wave intensity. This is known inverse square law, that is, intensity is inversely proportional with r square. If we plot a graph I against r square from the point source, the graph is like this. If the graph intensity against 1 over r square, the shape of the graph is a linear graph because intensity is directly proportional with 1 over r square. A sound wave flows out from the source in all directions. Hence, it is a three-dimensional wave and it's said to be a spherical wave like this diagram. Consider 2 points at distance R1 and R2 from the source, which is power is constant. Then, the intensity is equal to power per unit area. We know that the area for a spherical is 4 pi r square. I1 is equal to P divided by 4 pi r1 square. I2 is equal to P divided by 4 pi r2 square. The conclusion is I2 divided by I1 is equal to R1 square divided by R2 square. The amplitude of a sound wave can take one of two forms: the pressure amplitude, V0, or the displacement amplitude, S0. From this diagram, the more intense sound is produced by a source that has larger amplitude oscillation and has greater pressure maxima and minima, because pressures are higher in the greater intensity sound. It can exert larger forces on the object in encounter. So, we can say that sound intensity is directly proportional with amplitude squared. If we plot a graph intensity against amplitude, this is the shape of the graph. If we plot intensity graph against amplitude square, the shape of the graph is a straight line. Now, let's check our knowledge together by answering this question. From the diagram shown, calculate the ratio of I1 to I2 in 30 seconds. Are you ready? Let's go.
5, 4, 3, 2, 1.
Okay, time's up. The answer for this question will be explained in details by Mr. Z. Please check together.
These intensities are inversely proportional to the squares of the distances. So the ratio of the intensity of the closer source, I1, to the intensity of the more distant source, I2, is as shown here. We know that D2 equals 2 times D1, and inserting this into the equation, we obtain a value of 4.
Okay, thank you, Mr. Z. Now, we move to question number 2. The intensity of an earthquake wave at a distance of 40 km from the source is equal to 1.5 times 10 to the power of 6 watt per meter square. Question A. What was its intensity when it passed a point 0.5 km from the source? Question B. What was the rate at which energy passed through an area of 5 meters square at 0.5 kilometer. Please attempt this question. The answer will be explained by Mr. Zack again. Let's check our answers.
Using the inverse square law, we can easily calculate that the intensity equals 9.6 times 10 to the power 9 watts per square meter. The energy rate, E per T, can be calculated on the basis of the relation between intensity, energy, area and time. Thus, the rate at which energy passes through an area of 5 square meters equals 48 gigawatts.
Okay, to conclude our lesson today, we can say that sound intensity is inversely proportional with R square. Sound intensity is directly proportional with amplitude square. Sound intensity is directly proportional with amplitude square, inversely proportional with R square. So, amplitude is inversely proportional with R. For the last time, Mr. Zack will conclude our lesson today. Please listen to this video.
Rate of energy transfer, called the wave intensity, is defined as the energy E transported per unit time t across unit area A perpendicular to the direction of wave propagation. We can also express it as the power P transported by the wave per unit area A. If a point source emits power P, then this power is carried away by the waves. The intensity of a wave emitted by a point source is inversely proportional to the square of the distance from this source.
Okay, thank you, Mr. Zack. Thank you for your attention. Until we meet again. Bye!